Let's start with a super simple packet capture. First, we need to select a network. For this example, we'll go to the North Campus network. Packet captures are found by navigating to Network-Wide Packet Capture. The dashboard supports captures on switches, wireless access points, security appliances, and cellular gateways. We're working with security appliances, so we'll be using packet capture for security appliances on the North MX1 appliance. We can capture on any of the appliance's interfaces, but we'll be using the Internet 1 WAN interface. Let's begin by displaying the captured packets within this dashboard page by selecting Output, View Output below. We'll cover downloading to Wireshark in a later video. We can lower the duration to a shorter 30 seconds to gauge the amount of traffic. Let's leave the filter expression empty so that we capture all traffic. Then we'll select Start Capture to begin. When packets are displayed in the dashboard, we can find things like a timestamp, exactly when the packet was captured, the protocol used, the source IP address and port, the destination IP address and port, a sequence number, and the packet length in bytes. From the list of packets, we can find examples of things like ICMP echo requests and replies, ARP requests and replies, spanning tree protocol messages, TCP packets to destination port 7000. Note how TCP packets include extra fields like flags, sequence, window, options, and so on. Those are all normal parts of the TCP protocol. You might have noticed that most of the packets involve the IP address 192.168.0.153. That's the security appliance's WAN 1 interface address. So we're seeing packets it generated as part of the many tests it runs to gauge the link and internet health. Now let's use a simple filter expression to limit the capture and the output to contain only ICMP packets. To do that, we can use the filter expression ICMP. Let's select Clear Output to empty the list of capture packets, and then Start Capture again. Here we find that both ICMP echo requests and the corresponding echo replies have been captured. The request came from host 192.168.0.153, while the replies all came back from 8.8.8.8. We're able to confirm that traffic passed through the security appliance in both directions, outward and inward. Often we'll use packet captures to verify if some types of traffic are being blocked upstream from the security appliance. In that case, blocked or lost packets will be missing from the capture. Let's collect an example of this. We'll run the same ICMP capture, but this time notice that we're finding only the ICMP echo requests being sent from the security appliance 192.168.0.153 toward 8.8.8.8. No ICMP echo replies have been captured at all, which indicates that they're being blocked upstream and prevented from returning to the appliance. Of course, capture filtering isn't limited to just ICMP. What sort of filter expressions can we enter? Well, we can't just use anything that might seem logical, such as DNS, to capture packets related to DNS. In that case, the capture output shows that the filter is an unknown Ethernet protocol. That just means that we didn't enter the filter expression correctly. We'll explore filter expressions further in the next video.